Hi, this is Mark Kemper with EMS, and today we're going to do a demonstration of 3D scanning. For today's demo, I am going to use the ZScanner Z800 model. It is a handheld 3D scanner, laser-based scanner. And what you have on the scanner here is you have two main cameras that pick up the shape. And on this one, we have a third camera in the middle. It's a telephoto lens for high-res scanning. What's really nice about this is as I scan, I can push the high-res button at any time, and it'll pick up more detail with the high-res mode. Down here on the side of the scanner is where the laser is emitted, and on the front I have a trigger, and it's mounted to a computer, in this case a laptop computer via FireWire cable. The whole scanner weighs about 2 pounds, so it's very light. It's very easy to hold, very ergonomical, well balanced, and I simply hold it in my hand, pull the trigger, and start scanning. Now, before we get into the actual demo here, let's just talk about 3D scanning in general and why people 3D scan stuff. I've got a few sample parts here. I've got a sculpture. I have an impeller here. I've got a transmission bell housing, all very complex shapes. Also right here is for that impeller is the turbo housing itself. And if you look at something like this, if you don't have the CAD data, trying to get the CAD data gives you a couple options. You can 3D scan it, which we're going to show here, or traditionally people have measured it with scale and calipers, but trying to do something this complex is very hard to do. You've got this volute shape here, you've got more prismatic shapes here on the back side, again, more complexity in here. So trying to do this by hand would be difficult, it would take a long time, and it wouldn't be very accurate. 3D scanning it will be much faster, and we'll have much better CAD data when we're done. Now, the other thing you'll notice on this part is there's some targets on here, these reflective targets. The way the ZScanner works is it's a continuous scanning scanner. So it continuously scans as you move around. And in order to do that, you have to have some way of, some frame of reference or some positioning. And that's what these targets do. By spacing them every 2 to 4 inches, the scanner shines some LED lights onto the targets. The targets reflect back into the cameras, and it keeps position. It's really like GPS. The targets are like the satellites, and the scanner itself is like the receiver, and it triangulates its position from that. So you just simply put them on the part. A part like this, it takes about 5 minutes to put the targets on. As opposed to tripod-mounted scanners, where they'll take probably a couple dozen scans at least, single shots, and then they go in software and they have to merge them all together and align the data. And that's very timely. It's probably going to take a lot longer than the 5 minutes it took me to put the targets on this particular part. Now for the demo today, I'm going to do a smaller part, but this part has some nice curvature to it on the top, and then some more prismatic shapes here. It's a small part. Now you'll notice on this part there are no targets. What I have is a table. We can either target the parts. If it's larger, we tend to put the targets on the part. If it's smaller, we can just have a targeted table. In this case, it's a Lazy Susan, so I can rotate around and scan my part. So I'm going to place my part on the table. I'm going to put a little block here just to lift it up. You'll see why when we get into the software side of manipulating the scan data. But for the demo today, we'll go ahead and scan this, and we're pretty much ready to go. So I've got the ZScan software loaded up. I've got my scanner plugged in. The FireWire cable can be up to 15 feet long. So it's a very portable setup. I can go into very tight spaces inside a vehicle or an aircraft and get down in and scan probably where no other scanner can scan. All right, so we're ready to go ahead and get scanning here. I simply just hold the scanner over the part, pull the trigger, and start scanning. At the same time, I'm going to move my arm back and forth. I'm going to rotate the Lazy Susan and start collecting the data. Now what you see on the screen is both me scanning and the ZScan software that actually collects the scan data. And as I move back and forth, you can see the scan data. You see a few other things on the screen. You see the targets themselves. The red targets are targets that the scanner is using, and the white targets it knows about. All 3D scanners are line of sight, so if you can't see it, it will not scan it. And what's nice about a handheld scanner is I can articulate my arm and hand in any position to collect the data. So you can see here I'm rolling over to the side to pick up the sidewalls on this small part, rolling down here in the front, rotating the table. So this allows me to very quickly move all the way around the part and collect the data. Now we like to be about 10 or 12 inches away And to ensure that, there's a readout on the left side of the ZScan software, the color-coded bar. If I get too close or if I get too far away, I can see that. Also on the top of the scanner, I have the same readout, so if I can't see the screen while I'm scanning, I know that. And this just ensures that we get good quality scan data. That's kind of the sweet spot or the focal distance for the cameras themselves. So I simply just continue to walk around the part until I have collected all the data and I can visually see that it's all there. So we use the analogy of spray paint, and you just keep moving over the part, and you can scan over the same areas over and over. It's not going to hurt anything. You can't scan too much. So you keep walking around. You'll also notice I'm picking up some of the table of the Lazy Susan as I scan, and that's okay. That can be easily removed in the scan software. So we're not worried about that at all. But once I'm done scanning all the data, let's go ahead and zoom in here in the ZScan software, and I'm going to hit Stop Scan. What that's going to do is process the data, basically taking that raw point cloud data and converting it automatically into an STL file or a polygon file or triangulated mesh. It's really all the same thing. But what you see here is the finished data, so I'll rotate around and we can take a look at it and see we've got most of the data. Now if at any point we don't have all the data, we can simply just hit record scan again and continue scanning. So we just go back to scanning until we have all the data. So we can start and stop scanning at any point, which is really nice, and the software knows basically where we left off. So let's assuming we have all the data here again. We can hit stop scan and it'll process that. And then once that's done, we're going to output this polygon file or STL file, and then we're going to bring that into our 3D scanning software. We're going to actually process it and turn it into good quality CAD data, which would be a feature-based solid model or a surface model. So again, we can rotate around and look at it, make sure it's what we want, and then output it. And the next step will be then to convert this scan data into CAD data.